So we know as of right now, yeah, oh, actually, let me go back here real quick. Yesterday we had talked about when we were in our unit circle, we had positive, positive, negative, positive, negative, negative, positive, negative. We talked about that the your ordered pairs went cosine, sine. Thank you. We talked about how these all went ordered pairs because this is your x and y, x and y, x and y, x and y. So what's going to happen today is that we're going to take an ordered pair. We did a little bit of this in 13.2, or I'm sorry, 13.1, when we first put, let's say, let theta equal, cosine of theta was 3/5. And then I asked you guys, what's the tangent of theta? And you guys would place you would draw your draw a triangle and place it to go through. But today what we're going to do is something very similar to that, but we're also going to include ordered pairs that are negative. Okay? That way you place it on the unit circle to figure out where your functions lie. For example, if I say that we have an ordered pair of -3 and 4. If I have an ordered pair of -3 and 4, what quadrant does that go into? Second quadrant. Very good. So what I would do, it's placed right there. Now, what this means is that there is an angle whose terminal side lies at the point -3 and 4. You okay with that? That means that this value has a reference angle that's placed right above the x-axis. You all right with that? Now, my opposite in this case is what? 4. What's my adjacent? -3. And what's my hypotenuse? 5. It's gonna be a positive because your hypotenuse will always be positive. Because 3 squared, 4 squared, you get, because you're squaring everything out. So you have your radius, if you will, at 5. So if I know that my theta value is placed in the second quadrant and I have an opposite of 4, an adjacent of -3, and a radius of 5, I can list all of my trig functions, all 6 values. If you think about that, we have cosine, sine, and tangent. Now, if I look at this, I'm doing them in order of alphabetical, instead of doing sine, cosine, tangent, because in your minds, if you start thinking if x's come first, I always think it's a little cleaner. Cosine is adjacent over hypotenuse. Everybody okay with that? In this case, it's -3/5. Now, what I'm going to do here is I'm going to call this 5 the radius. Okay. I'm going to call this 5 the radius because a lot of times in the textbook here, since we're placing this thing into the ordered pairs, what we're looking at is what is it? It's created out of a circle. Okay, because we're going around something. We're going to call that 5 the radius. So cosine of an angle is going to be x over r. Sine then would be y over r. What's tangent going to be? Y over x. So it's opposite over adjacent. It's going to be y over x. Okay. Now, if I have cosine is x over r, what's the inverse trig function of cosine? Secant. So what's secant going to be? Very good. That gives you secant of theta at r over x. What's the inverse of sine? Cosecant. Very good. Cosecant's ordered pair, in terms of x's and y's and all that, r over y. And then cotangent, which you so eloquently discussed a second ago, Emily, was? Very good. And these values will work no matter where your ordered pair lies within the quadrants. That's how sines, cosines, tangents work. because you have an opposite. We talked a little bit about this yesterday. Your opposite is a vertical. Your opposite is always a vertical no matter where it goes. Even if it's in the third quadrant, when you have a reference angle. If your reference angle is down here, it's looking at an opposite, it's vertical, but it just so happens to be, it's just moving downwards, so that vertical becomes negative, hence why sine is negative there. This is where trig really gets tricky. I'm tricky with it. It's time to stop. Collaborate and listen. Sure. Is ice back in brand new condition? Something grabs a hold of me tightly. Will or stop though? I don't know. Let's beat all that. We did this. We did that. All right, let's do this one. Let's do the 6 trig functions whose angle has a terminal side at the point -12, -15.
One of my friends had one of those, and we keep shooting them at the ceiling, and one of them got stuck on the ceiling.
Yeah.
We spent like the rest of the class like trying to get it down.
So if I'm at -12, -15, what quadrant do we wind up in? Good. So we wind up in the third quadrant. So let's see here. Be okay with that? Now, when I draw my vertical, I always draw it back to the x-axis. So I draw my vertical back to the x-axis. This gives me a -15 here, -12 here. How do I figure out what my radius is? 0. So I do 12 squared. What is it? 341. Yeah. You wanted to say 5, 12, 13, whatever, because that is a triple there. But you, yeah. So, excuse me, your hypotenuse of this one was what, 2√41? Okay. So my hypotenuse here, my radius is going to be 2√3? I'm sorry. 3√41, excuse me. Okay. Do you guys remember how to simplify out the radicals using that calculator? Yeah. Why? Yeah, divide by x squared and use your table. Okay. So here's what we're going to do. We're going to list out all the trig functions in simplified radical form of that angle. We're going to find all the trig values of that angle. So we have cosine, sine, and tangent. I usually start with these first, and then I just flip the fractions. Cosine is x over r, so it's going to be -12 over 3√41, which means I'm going to have to simplify that. Okay. This one's relatively simple because you have the -12 and a 3. What do you get out of that? Yeah, you get -4 over the √41. And then how do you move the √41? Move top and bottom by √41. So your answer winds up being -4 √41 over 41. Okay. Your value of sine then is going to be -15 over 3√41, which simplifies to being -5 √41 over 41. Very good. And that makes sense that they're both negative because cosine and sine are both negative in the third quadrant. Your tangent then is going to be opposite over adjacent. Negative 15 over negative 12, which means so it's going to be y over x. What's a negative divided by negative? It's positive, which means this simplifies out to being 5/4. Now here's the thing. Remember how it went positive, positive, negative, positive, negative, negative, positive, negative? That was for sines and or for cosines and sines. Where's tangent positive? 1, 3, and where's tangent negative? 2 and 4. So tangent is positive, tangent positive, tangent negative, and tangent negative. And the reason that happens is because tangent is y over x. Since tangent is y over x, you have to have both sides being the same, SIGN, in order for the tangent to be positive. It works the same with reciprocals. Cotangent would be positive first and third. Cotangent would be negative first and third. So those are my normal trig functions. My inverse trig functions, because these dual things here is a little easier so you can see. My inverse trig functions, sometimes it's easier to go off of your non-simplified to get your inverse. For example, if we wrote down originally cosine of theta was negative 12 over 3 root 41, that means the secant would just be the flip of that. Are you okay with that? So if I flip that, I don't have to worry about rationalizing anything. I just have to simplify that fraction. And I just get negative root 41 over 4. Okay. That way you don't have to go back and write down that secant of theta, is negative 41 over 4 root 41. And then simplify it out of that. That's just a nasty mess. It's much easier just to go from the original and then go from there. Does that make sense? By using the unrationalized version, you flip that one first, and then it's just quick. So you get negative 4 root 41. If I do the same thing with cosecant, if I'm looking at that one, it would be 3 root 41 over negative 15. Does it matter where you put the negative? And then lastly, cotangent is just going to be 4/5. Hey, don't make fun of people that can't make the sound. Make teeth. I know. It doesn't go as nice. I met a metal railing that I didn't like. Tripped down the stairs and face planted in a metal railing. So it wasn't rad. It was not very rad. It was very unrad. There's a certain degree to the difficulty of that fall. It was unrad degree to. My parents had a rather large angle of depression for that problem. It was bad. Oh well. Here, do one more. Yeah, we got time. Actually, you know what? We're running short here. Let's do this instead. Quadrantals. Yesterday, we neglected to talk about one bit of rather important information upon the unit circle. The thing that we neglected to talk about on the unit circle were these things called the quadrantals. The quadrantals are the ordered pairs where the unit circle crosses the axis. So you have an ordered pair that crosses the axis at 0, pi over 2, pi, and 3, bless you, and 3 pi over 2. Those values have certain things. See how close I was to making my circle here. That's pretty darn close for, that's not too bad. Thanks. Let's make that a little larger. Anyway, so when we dealt with this thing called the unit circle, the reason we gave it the term unit is because we gave it a value of 1. So if you go to the right, what value are you walking, your x or your y? Your x. So at 0, your ordered pair is 1 and 0. At pi over 2, what's your ordered pair? 0, 1. And then down here you're at, what's the cosine of 0? 1. What's the sine of 0? What's it? Go back. Ordered pairs. Your x value is cosine, your y value is sine. What's your cosine of 0? Stop overthinking. Remember how we said this? We've said this many times now. Your x and y stand for cosine, sine. Correct. Because if you think about it, this value here is your radius, and that is equal to 1. So when you go through your cosine of theta, or cosine at 0 is x over r. Well, x and r are both 1. What's 1 divided by 1? 1. The sine at 0, well, that's y over r. What's the value of y at 0? 0. And 0 divided by 1 is 0. What's the tangent at 0? Tangent would be y over x, which is, well, what's your y value? 0 over 1. And what's 0 divided by 1? 0. Bless you. Now, and you've heard me talk about this a little bit. The whole reason that the sines and cosines rotate around, if you start at cosine at 0, at 90 degrees, I'm sorry, cosine of 0 is 1, 90 degrees it's 0, at 180 degrees it's -1, at 270 it's back to 0, come back up to 360, you're back to 1. What's happening here is you start something at 0, you end something at 2 pi. Instead of going full circle, we're cutting the circle and stretching it out. Halfway between 0 and 2 pi is pi. Halfway between 0 and pi is these values here, 0, pi over 2, pi, 3 pi over 2, and 2 pi. These guys are just your quadrantals. These guys are your breakpoints on your axes as you're going around the circle. So if you think about what cosine does, cosine starts where? It starts at, its x value is 1. At pi over 2, its x value is 0. At pi, it's -1, 0, and it goes back up to 1. It's curved. It's curved. Watch what sine does. Where does sine start? When you're at 0, what's your value for sine? What's my y value at 0? 0. At pi over 2, it's 1. This is why everything works. This is why everything works. Quadrantals. Your quadrantals are 1s and 0s. It's a matter of which one are you placed at. Now, if I wanted to see what is the inverse of cosine? Secant. So what is the secant value at 0? So if I want to look at the inverse of those, the secant of 0 is going to be 1 because it's r over x, which is 1 over 1. You flip it and you still get 1 over 1. Now, what about the cosecant at 0? Remember, it's going to be 1 over 0 now, which is undefined. It's undefined. If I do the tangent at 0, which is now 1 over 0, which is also undefined. So if you have a sine value that's 0, that means the inverse of 0 is undefined. And if you have a value that's undefined, that means its inverse is 0. The inverse of 1 is 1. The inverse of -1 is -1, because you're just flipping the fractions. Yes, ma'am? Oh, did I write tangent? Thank you. I'm sorry. Sorry about that. Okay. And that also works with the same idea is, if I look at this red graph here, that red graph was sine. Remember that? What's the inverse of 0? Undefined. When you have an undefined value on a graph, what do you have to draw? Vertical asymptote. What's the inverse of 1? 1. What's the inverse of 0? What's the inverse of -1? -1. What's the inverse of 0? Now, somewhere in between 0 and 90 and pi over 2, there's 1/2. What's the inverse of 1/2? 2. Somewhere in between here, there's also a 3/2 or another 1/2 value. So here's your cosecant graph. We're getting there. Everything that we do is going to literally wind up being based upon these quadrantals. Okay? I don't know. It's good times, isn't it? You're shaking your head, Miss Mac. I'm telling you, you're going to be fine. I'm telling you. Okay? I'm telling you. We will. We're not going to do graphics when we get back from break, though. Do those. First group are a bunch of find the 6 trig functions at a specific value. There are 3 problems that have list them off the quadrantals, and then there's a couple of reference angles. What's that? All of them. So you're good at doing all of them. So we'll just keep that up. So remember, the first chunk. The first chunk is literally, right out the 6 trig functions at a specific point. So you'd be doing some simplified radical form, nothing crazy. There's a couple of quadrantals thrown in there, and then the last, I want to say 6 problems or so, are just find reference angles. I want you guys to spin to find that reference angle of how far you are off the x-axis, because we use that starting tomorrow like nonstop. It's just, I didn't talk about it, but I know you can do it, so I'm just going to see how you do. I love this stuff. Because then it does this then. It's all shift points. It's all about figuring out where your period comes into play, how it's been adjusted out, and where left fractions. That's always how far you're off the x-axis. Same thing. Yep. Remember, at reference angles, how far you are bounced off the x-axis. Always x-axis. You guys sound so upset about graphing. I love it. Don't die.